Hi there. This is going to be a quick video about the ideology of the UK government in regards to renewable energy, and specifically to do with a research briefing that appeared in the House of Commons Library on the 13th of February. And just let's go through it and highlight some of the government's gobbledygook in it. So just before we do that, this is the document that we're going to analyse here if anybody wants to reference it. It's related to the UK Government Clean Power Act 2030 and their action plan of how we are supposedly going to get to supposed clean power generation by 2030 and the electricity grid network. Just as a little background, they're using words power and energy in the report, and they're interchanging these words without actually understanding what they are. It may not be deliberate, but they're interchanging these words where they lose of what the significance of what physical quantities they're actually talking about. So power is the rate of doing work, and energy is the capacity to do work. Essentially, if you want to convert energy, you have to do work. Power is the rate of doing work, which is normally done in per second, although you can average it out, but normally it's the rate of doing work. It's the instantaneous conversion of energy. Energy is the capacity to do work. It's power times time. Official unit is joules, which is essentially watt seconds. So we need to understand the significance of how these physical quantities are actually defined. They are related, but they're not the same thing. Electrical power is voltage times current. Mechanical power, for example, if you pick a box up or you walk along the street, the mechanical power exerted is force times the distance. Electrical power is normally measured in kilowatt hours in a domestic house. So it's normally kilowatt hours, megawatt hours, gigawatt hours, terawatt hours is the energy. Okay. Terawatt hours, time is in the hours. So we're defining the units of energy, not defining the units of power. That is watts. And paying attention to the SI notation in here, which is important for the analysis as well. Small k is 10 to the power of 3. It's shorthand to avoid having to write all the zeros in, where it's actually very easy to drop a zero or add a zero in and make a mistake. So we use SI notation. Mega is a million, 10 to the power of 6. Giga is a billion, 10 to the power of 9. Tera, 10 to the power of 12. So tera's in here. Why? Well, because the consumption in the UK for electricity last year is 263 terawatt hours per annum. The per annum is important. When you're defining energy, you need to define over what time scale it's actually being measured. If it's over per annum, 263 terawatt hours of electricity consumption in the UK, if we have 70 million people, that averages out to be 3.7 megawatt hours per person per annum. If we specifically go to this research briefing, there is some gobbledygook in here where they don't really understand power and energy. So, for example, if we look at this particular summary paragraph here, apologies for that. What he's saying here is this is particular government gobbledygook in here. So this, if you read through it, what it's saying is at least as much power as Great Britain consumes in total over the year. Well, the word consume in power is not the right terms to match up. What they're meaning here is energy over a year. So the consumption over a whole year per annum, yeah, power is instantaneous. The national grid system has to be able to have dispatchable power at any instant in time to supply the demand. Otherwise, there's going to be blackouts. The energy tends to be averaged out over a year. So, for example, if we go to the grid watch here, we can see here on a reasonably windy day, we can generate 7-8 gigs. Not a particularly windy day, but we still need gas backup to provide the near 40 gigawatts of instantaneous power demand, 39 gigawatts. Nuclear is base load, and we're still importing electricity from Europe there. So if we go back to here, this is essentially gobbledygook. They're mixing up the words power and energy. And this doesn't seem to make too much sense. What my take on, at least 95%, what they're meaning over a year, by 2030, they want 95% of the generation to be from so-called clean sources of essentially solar and wind. Yeah, and if we're in particular times, and if you remember back to 9th of January at the start of 2025, where the UK came very, very close to having blackouts, that was a particular issue that day because we were in the middle of a high pressure. We had effectively zero wind generation. Doesn't matter how many wind turbines you have, if there's no wind, you will essentially get 0 gigawatts out of it. So what they're saying is 95% over a year generation with the 5% backup from essentially gas supplies here. So this is actually doesn't, it's a bit of gobbledygook, actually doesn't make sense in terms of mixing up power and energy. If we go further down here, there are some other issues here where they redefine this metric, these two metrics here. Clean sources produce at least as much power as consumes in total. Well, consumes is energy, it's power over time. But then they're using the term power here. So there's a mismatch. Power is instantaneous. Okay, energy is work done over time. So this doesn't, again, makes too much sense. This makes sense in terms of per annum, they want by 2030 to generate from clean sources, essentially solar and wind. That makes sense. This doesn't make sense. If we go further down, there is an actual problem with this word here. It's saying the UK has been a net exporter of electricity for the last 4 decades. That's just completely wrong. That should be a net importer of electricity. For the last 4 decades, the UK has never exported any substantial amount of electricity. On certain days, we're having to import up to 15% of our electricity. That is simply not energy security. It just completely goes against that. And there are some other charts here where they're interchanging the word power and energy and don't fully understand the subtleties between it. So they actually, in this chart here on the left-hand side vertical axis, it's actually got the terawatt hours here. Now that does match up with the figure that we quoted earlier in the slides here of 263 terawatt hours. And if we go to this, that does actually match this graph, and this is per annum. That it's not power consumption, it's energy consumption. Yeah. And then clean generation, yeah, the wording in here is absolutely spot on. What they're really saying is we're not quite there yet. We're in 2025, or this is up to 2024. There's still a shortfall of probably, well over 100 terawatt hours. So that gap is only going to be narrowed if there is more solar and wind. However, if the weather goes against you, because solar and wind are weather dependent, you're still going to need the gas backup. And they openly admit that in this document. So this video is just to further explain the difference between power and energy. Power is generally speaking instantaneous, it's the rate of doing work, and energy is over time. So they're actually interchanging the words and not being accurate, which is a little bit of a worry in terms of do they really understand what they're on about. This down here, yeah, power consumption, again, this is not correct. It's energy consumption. Yes, the UK energy consumption, electricity energy consumption from the national grid has been falling steadily. Why has it been falling steadily? Well, essentially, we're being deindustrialized. So the heavy engineering is largely gone. And also electrical equipment is much more efficient nowadays, even with the added internet, tablets, laptops that people use ubiquitously now, that it has steadily fallen over the years. But there is still a gap. It is quite significant. They're going to have to match well over 100 terawatt hours if they're going to get up to the 95% clean generation. Highly unlikely it's possible for conditions during winter where you're in a high pressure, it's very cold, there is high electricity demand, and the weather just goes against you. We will still be using gas generation. Now, what we've done with all the different types of electricity generation, that is the real reason why your electricity bill has gone up 3 times in the last 12 years. It's not, apart from the peaks with the Ukraine war, peak in the gas price in 2020 or 2021. Gas is not the prime driver in this. It's because all these types of generation sources have to be paid for. And at the end of the day, it's the end user that pays for that. That's the only significant cost that comes into play. That's why UK has some of the highest electricity supply prices in the world. And it's not going to come down. Clean sources, wind and solar, are not going to go there because you're having to back it up either with gas or batteries. And once you do that, the figures just get blown out. The electricity bills will never come down unless there's going to be a more economically pragmatic way of generating electricity. Thank you for watching. Please subscribe.